Hello everyone. I'd never thought one day in my life I would be hosting more than 1500 people live from 42 countries in a virtual setup like this. This is thrilling. I'm excited and a bit nervous too. A very warm welcome to the Data Platform Virtual Summit 2020. My name is Amit Bansal and I'm leading the DPS event this year. This is very humbling. I'm a proud member of this wonderful community that undertakes so many learning initiatives with one common objective: connect, share, learn, and grow together. What you see on the screen is just a glimpse. There are dozens of such initiatives that keep us connected. So a big round of applause for the SQL family. The last 15 years have been so rewarding. Since 2004 to this year, it has been an incredible journey of community work that I can never express in words. In 2004, we took baby steps with our community. I remember that 7 attendees attended the so-called first SQL user group meeting in India. And today, as I speak to you, we have close to 215,000 members from 118 countries spread across 14,000 organizations. This is an incredible feeling. In the last 15 years, we have got incredible support from our speakers, volunteers, community champions, sponsors, and knowledge partners. But truly, if there is someone behind this organic growth, it is you. Organizing an event like DPS is like making a movie, where you watch the 2 hours of the final output, but a whole year has gone into the making of it. I take this moment to thank our core team members, across the globe volunteers, speakers and moderators, advisory council members, community champions, and last but not the least, our knowledge partners. Dell Technologies, Red Hat, SQL Maestros, Redgate, DB Watch, Data Whale, and a special mention for Microsoft Azure. If there is one organization that understands community so well, it is Microsoft. So thank you, Microsoft, for supporting our community work. Community is just not about us. There is another section of society that is so underprivileged. I am part of Mahadevi Foundation, where we support differently abled individuals, old age homes, and a special focus on child education. You will be happy to know that a small percentage of the revenue that we generate from this event goes into such noble causes. So yes, you are indirectly contributing. Yay! Now it's time for someone special. We all have been eagerly waiting for this moment. So friends, put your hand together and join me in welcoming the keynote speaker of DPS 2020, the one and only Rohan Kumar.
Hi, welcome to the Data Platform Virtual Summit. My name is Rohan Kumar, and I'm the CVP of the Azure Data Group at Microsoft. I want to start by thanking Amit Bansal, the SQL Server Geeks, and the Data Platform Geeks for inviting me to speak. Back in 2004, the seeds of this event first took root when one person traveled across India to share a passion for SQL Server. From those humble beginnings, the DPS Summit was created to bring together thousands of participants across Asia. This year's move to a virtual platform casts an even wider net. Today, you're streaming live along with participants from more than 30 countries. Whatever time zone or season you are in right now, thank you for joining. It's hard to believe it's been almost a year that we've been living in this virtual world of work from home, school from home, shop from home, and vacation at home. I've even heard of people attending theater productions and weddings from home. It's amazing when you think about the ways we've adapted. In the midst of all these changes, though, your role has changed as well. Organizations now look to you for strategic guidance on how best to adapt to today's environment and develop creative new ways for solving the challenges we face. You are at the heart of the solutions that keep our from-home world working, and it's through your ingenuity and perseverance that we'll emerge stronger than ever before. When you stop to consider all the technologies and skills you need to support modern day digital transformation, though, from managing structured and unstructured data on premises, in the cloud, and at the edge, to finding new efficient ways to drive insights out from all that data can be overwhelming. Admittedly, it's a big stretch for any one person to learn. That's where the Azure Data Strategy comes into play. We are building an end-to-end data platform that empowers you to use your skills across services and technologies. We do that by making the DBA and BI skills that you have today transferable across key services. What I mean by this is, if you can do things like handle configuration knobs, run performance troubleshooting, or set up encryption in SQL Server, you can apply the same skills to the cloud using Azure SQL databases, to your edge computing environment with Azure SQL Edge, or even to the other clouds through Azure Arc. Those skills, as well as your experience with SSRS, can be applied to big data analytics, machine learning, and reporting too through Azure Synapse Analytics and Power BI. When it comes to NoSQL and community open source databases, Azure services help you feel right at home with familiar enterprise-grade management tools and security controls, and it offers support for your favorite languages and developer frameworks. For example, if you know how to use SQL Server Management Studio, you can use Azure Data Studio. Likewise, if you use SSIS to move data on premises, you can package it up and deploy it directly to the cloud using Azure Data Factory. We've even built in consistencies with Azure Databricks by making it easy to use your favorite development languages like .NET, Python, Scala, R, or Spark SQL. And of course, we support T-SQL across all our SQL services. All of this comes together to create a complete end-to-end data platform on Azure that makes it faster and easier for you to drive digital transformation for your company. Let's dig in and I'll show you what I mean. I'm guessing you've heard of Azure SQL before. Did you know that Azure SQL no longer just refers to Azure SQL Database? Today we use the shortened name to talk about Azure SQL Family, a collection of both infrastructure as a service and fully managed platform as a service offerings. You can use these services to support a wide range of application patterns. Let's run through the 3 services on screen to briefly talk about which service you might want to use and when. SQL Server on Azure Virtual Machines works great for lift and shift scenarios in which you want your SQL workloads to maintain 100% compatibility with the original database and the operating system. With the SQL Server Resource Provider, you get IaaS Plus benefits including automatic patching, backup automation, and easy HA setup. Azure SQL Managed Instance is an excellent option for modernizing your existing SQL Server applications. It has the broadest SQL Server compatibility of any fully managed service, making it possible to modernize apps in the cloud with minimal code changes. And finally, Azure SQL Database supports modern cloud applications on an intelligent managed service that includes serverless compute. Azure SQL also offers hyperscale databases that enable unlimited scale for your growing workloads and serverless options for the applications with intermittent traffic patterns. All the service tiers are priced at industry-leading low total cost of ownership. I know you probably hear a lot of talk about where SQL Server runs best, but it should come as no surprise to you that SQL Server workloads run best on Azure, period. Our SQL Server engineers work alongside the Azure team to make sure this is true in every case. Here, we've got a few points about what makes Azure SQL the best destination for SQL Server. In addition to providing evergreen SQL, which means you're always running the latest version of SQL Server and never have to upgrade, Azure SQL also handles administration tasks, including patching, updates, backup, and HA setup for you so you can focus on your higher priorities. And it offers intelligent security and performance features built in. As you can see on the slide, we are creating ways to measurably help you boost productivity, ROI, and the life of your existing assets. And our investments in security are unparalleled in the industry. Taken together, this depth of product innovation and unbeatable pricing offers give you the best innovation and price performance available. As a matter of fact, a set of benchmarks from analyst firm GigaOM showed that Azure is up to 3.6 times faster and up to 84% more price performant than SQL Server running in AWS. We are constantly innovating on Azure SQL, to help you get the best value and performance for your money. I'd like to highlight two recent enhancements we've made to Azure SQL. SQL IaaS Agent Extension optimizes cost and simplifies management of SQL Server on Azure virtual machines. All you have to do is register your VMs within the SQL blade of the Azure portal by checking a box. Once you've activated the IaaS Agent extension, you get better visibility into all your SQL workloads on Azure and access to additional manageability and automation that lets you do things like switch between different license types like AHub, pay-as-you-go, or free HADR with no downtime. Easily set up always-on availability groups plus encryption. And automate storage configuration using best practices. This month, we've added SQL Server Analysis Services pre-configured images to the Azure Gallery alongside SSRS images. These images make it fast and easy to migrate on-premises SQL Server data models and reporting to Azure. These are just 2 of a dozen updates being made to the Azure SQL family. Next, I'd like to bring in Anna Hoffman to show you what we're doing to make it even easier to deploy SQL Server on Azure virtual machines and to optimize for performance and cost. Welcome, Anna. Thanks for joining us today.
Thanks, Rohan. Today, I want to show you how we're making it easier for you to migrate to Azure SQL, specifically to SQL Server in an Azure VM. I want to show you not only the unified create and view experience for Azure SQL, but also how we're continuously working to make it easier for you to run better, faster, and cheaper. The new streamlined experience for storage configuration, which I'll show you, helps you optimize your performance, I/O, and achieve balanced throughput without over-provisioning your disk based on VM capacity. So let's start in the Azure portal. Here I'm viewing Azure SQL, meaning I can see my VMs, manage instances, and databases all in one place. I can select Add to create a new deployment. Not only do I see all the Azure SQL deployment options in one place, but I can also click in and learn more about the different options and what to use when. Today, we'll look at SQL Server and Azure VMs, and this is great because we put all of the images with SQL Server pre-installed in one place all the way back to SQL Server 2008. Today, we'll pick SQL Server 2019 Enterprise. Now, I'm brought to a similar create experience, which is going to ask for things like subscription, resource group, and other items like availability sets or availability zones if my workload requires that. Under size, I have lots of options to choose from, but I immediately get some recommended sizes, which helps a lot. You can see I get a preview of the monthly price, which I'm going to come back to. I have to put in a username and a password for my virtual machine, and then I can take advantage of Azure Hybrid Benefit Savings if I already have an existing Windows Server license. As you can see, my estimated price per month immediately dropped about 30%. Now, there are other things I can configure for the VM, but I want to hop straight to the SQL Server settings. I have options around networking, SQL Auth, and Key Vault integrations, but I want to skip to where we've recently added a new, easy way to configure storage. If I click into Configure Storage, I can see a simple way to specify my workload. Azure will then take care of setting the trace flags that will help me optimize for, in this case, a transactional workload. I can then configure my data storage, which is preset at some of the best practices. Data disks in their own drive, with P30 storage, which I can scale up or down easily, and I can see the resulting max IOPS and throughput. I can then alter my number of disks accordingly to create a storage pool. Now, if I change my number of disks to 3, I get a warning that I might not get the performance I'm expecting because I will hit the capacity of my VM. So I can go back and select a larger VM or choose a lower number of disks. For this, I will just use 2 disks in my storage pool, which still gets me 10,000 IOPS and is great for my workload. I can then configure my log storage, but the recommendations are in line with the SQL Server best practices, so I don't really need to change anything. We can see the default is to move TempDB to the local SSD drive on the VM. This is fast local storage to the VM, so the I/O generated against this drive does not count towards the disk or VM I/O limits for remote storage. This is particularly important if I have a TempDB heavy workload. The local drive is ephemeral, meaning that if the VM restarts, the data stored on the drive goes away, but since TempDB gets recreated when SQL Server is restarted anyway, this isn't really a problem. When you configure it through the portal the way we're doing now, a job is created that will automatically recreate the required folder structure whenever the VM is restarted. If you were going to self-install SQL Server, you would need to manage this yourself. This is just another example of how we're helping you to be set up for success. Now, there's also some extra stuff I can do, like getting more Azure Hybrid savings if I have an existing SQL Server license, setting up and configuring automated patching and automated backups to meet my requirements and schedule, and even pre-enable machine learning services so I can do machine learning with R right off the bat. I can now select Review and Create to review my options and kick off the deployment. This takes a few minutes, so I have a SQL VM I already deployed here with the same configuration. If I go into disk, I can see the correctly configured data disks, including setting them to read-only host caching, which is going to allow me to achieve the highest performance. I can even hop into this SQL VM, which comes, of course, with SQL Server and SQL tools like SSMS installed already. And I can connect just as you all have done many times because it's just SQL. We can see that the latest CU has already been applied. If I go into the server settings, I can verify that my drives were set up properly. I can even look at the storage pool. And going along with the theme, all of the properties for my storage pool disks have been set up in accordance with the best practices. So I don't have to configure or do anything extra. I can just get to work. So whether you're considering SQL database, SQL managed instance, or SQL Server in Azure VM, you can be sure that we're continuously innovating to make it easier for you to get the most out of your deployment. Thanks, and back to you, Rohan.
Thanks, Anna. I love the new storage configuration settings and recommendations. Those seem really useful. I'd like to close this section by sharing a customer migration story with you. This is from a Brazil-based technology company that migrated from on-premises SQL Server to Azure SQL Database Hyperscale to improve response time and fraud detection for clients.
ClearSale is a global technology company, so we are specialized in fraud detection, identity authentication, and credit score in more than 150 countries. Every day, we receive a huge amount of data. Since we are running on-premises solutions, we couldn't scale vertically in a way that our data were growing. The partnership between Microsoft and ClearSale was really great. Their ideas and support really helped us to move our solutions to the Azure environment. With Azure now, and combining all the products that Azure offers us, allows us to scale and achieve these faster responses that our clients need. The scalability is the key for us in this migration. With Microsoft solutions like Azure Hyperscale and Azure Synapse, we have a comprehensive environment for this job. Our solution works with real-time predictions using advanced machine learning models. Having Azure Hyperscale to use as a data serving layer for our APIs and other workloads that we have really helped us with regular maintenances that usually data services administrators have to do. Azure Synapse was able to solve a substantial problem for us. We can build pipelines without worrying about storage space, for example, or processing power, as it is really easy to scale. That was one of the things that we realized after the migration, is that everything combined would allow us to have the best response time and the best fraud protection for our clients.
ClearSale is a great example of how companies leverage cloud services to get a better idea of what's going on in the world in near real time. Today, we're seeing more new scenarios spring up from the edge than anywhere else as IoT devices become a part of our everyday world. Of course, edge computing also presents a lot of challenges like poor connectivity, increased threat exposure, system incompatibility, and so on that can take a lot of time and energy to learn and address. Not anymore. With Azure SQL Edge, you get the same Microsoft SQL platform that you use on premises and in the cloud at the edge, bringing intelligent capabilities to where your data lives. Optimized for IoT servers, gateways, and devices, the small but mighty database features built-in data streaming, storage, and AI support to help you drive real-time insights, whether on the factory floor or on a remote wind farm. Only on Azure can you access native SQL codebase consistent across your entire data estate. It's the same industry-leading platform that your teams already know and trust, now deployed across IoT gateways and edge devices, something no other cloud provider can offer. Also, only with Azure SQL Edge can you natively integrate with other industry-leading Azure services such as Azure Blob Storage, Azure IoT Hub, Azure Machine Learning, Azure Kubernetes Service, and Azure Data Studio. Let's dig in for a second to see how consistent SQL code and native data movement play out in Azure SQL Edge. Azure SQL Edge solves a core customer challenge of integrating IoT data from numerous sources to your data center and to the cloud using the same SQL DBA skills you would elsewhere. The investments we've made in T-SQL allow you to bring your existing skills to the edge. Now with Azure SQL Edge, you can utilize built-in capabilities like T-SQL streaming to help with native data movement. Choose operational databases and targets best suited to your needs as an application developer or operator. And simplify and secure your Edge architecture with natively integrated Azure Edge family of products and services. Azure SQL Edge is generally available. Which leads to one last point. We've made it simple and easy to get started, including all new pricing models right-sized for IoT. You can get started today in the Azure Marketplace for as low as $10 per month per device. I'd like to tell you about how one of our partners, Raven, is using Azure SQL Edge to solve industry-specific problems for its customers. Raven's mission is to provide complete IoT solutions to customers across industrial, commercial, and health sectors. They offer an easy-to-use codeless solution builder that collects data from any IoT device or industrial software. And it funnels the data into a real-time operational dashboard where businesses can run machine learning and predictive analytics. On the back end, the Raven solution is fully hosted on a variety of Microsoft Azure services, including Azure SQL Edge. While there are many scenarios for Raven's technology, Vasiya Krishnan has a demonstration ready for us that shows how a healthcare customer might use the solution to monitor and track critical assets such as ventilators in the hospital. Vasiya, thanks for joining today.
Thank you, Rohan. Hi, everyone. Thank you very much for joining us today. I'm Sia, and I work as a program manager with the Azure SQL Edge team. Today, in this demo, we are going to see how Raven and Microsoft are working together to make healthcare IoT solutions more intelligent. For the purpose of this demo, assume that I am the maintenance supervisor for a hospital. One of my key responsibilities is keeping our ventilators operational, a time-consuming but a critical task in the age of COVID-19.
What I have in front of me is Raven's customized dashboard. You can see the map of my hospital with the location of multiple ventilators across the buildings. If you look at the data closely, you will realize that it is often time series in nature. I'm tracking multiple data points for each of these ventilators, such as which room are they located in, what is the temperature of the device in there, battery state of the ventilator, and also battery of the RFID tracker on the ventilator. This was made possible by Azure SQL Edge that has been deployed on these devices. Native data streaming capabilities on Azure SQL Edge enables the devices deployed on the hospital floor to capture the real-time information from the ventilators. This helps me make most of my assets without having to spend my whole day conducting in-person checks. In addition to giving me visibility into imminent failures by collecting data over time and combining it with information like service records, I can start to build a proactive maintenance plan to minimize downtime and maximize quality of care. The data that I have been collecting at the edge is aggregated and sent to the cloud storage. In this case, it's an Azure SQL DB. This is possible because of the native data movement features supported in Azure SQL Edge. And by sharing the same data with my medical colleagues, they can remotely review and validate the device configuration irrespective of where they are located and take timely actions as needed for the patient's well-being. Let us now see how SQL Edge makes all of this possible. SQL Edge uses the same SQL engine as its data center-based counterparts, and as a result, I can use the tools I'm already familiar with, like SQL Server Management Studio, or in this case, Azure Data Studio. Just like any other SQL server, I can use a full range of T-SQL query syntax and get full intelligence support in this editor. From this query, you can see the raw data coming from the ventilator sensors across my hospital. The data frequency and volume means relaying this to the cloud for analysis isn't a good choice. Let's see how SQL Edge can make sense of the data locally. Azure SQL Edge provides a native implementation of data streaming capabilities called T-SQL Stream. So it provides real-time data streaming, analytics, event processing to analyze and process high volumes of fast streaming data over multiple sources simultaneously. As with stream analytics, T-SQL streaming recognizes patterns and relationships in information extracted from a number of IoT input sources. In this case, these are the ventilator devices that are there on the hospital floor. So you can use patterns to trigger actions and initiate workflows. So T-SQL streaming works in exactly the same manner as Azure Stream Analytics. We will be creating a streaming job in this case with anomaly detection built in, and then post that we will be starting the streaming job, and at the end the result that we are going to see is what are the anomalies with respect to the temperature of the ventilator that is coming up on ventilator number 3. Let's go ahead and run this query now. So here you can see that we have a score that has been assigned to each of the values that are coming out from the table, and also we have also seen whether it is an anomaly or not. While alerts and other key operational telemetry messages are best routed to the cloud via IoT Hub, bringing aggregated data sets up to the cloud can be more efficiently done through Azure SQL Data Sync. Because SQL Edge is built on the latest version of the MySQL Server database engine, any data synchronization mechanism that's applicable to a SQL Server instance can be used to sync data to or from SQL Edge instance running on an edge device. So when you look closely into the logs that is available over here, you will see that the sync has been happening successfully every couple of minutes with this database that is on the edge. SQL Edge also has built-in ML capabilities with native support for running Onyx models inside the database. Onyx is Open Neural Network Exchange. And while Edge is the ideal place to run inferencing, mainly to avoid massive real-time data uploads, which is an expensive task, it is not the best place to build models. Once the data is in the cloud, as you can see here, I will be using Azure ML capabilities to train or retrain models that need to be deployed to the edge for better inferencing and anomaly detection. So now let us spend the next few minutes trying to build a model that is going to be used to predict a device failure before it results in a complete service outage. First and foremost, I'm going to import the data set that I have sent to my Azure SQL DB Cloud Target. Once we fetch our data set, I'm going to be using AutoML to evaluate different model types. And as you can see here, I'm running 10 iterations. You can run more than 10 iterations in order to help you choose the best model out there. And what AutoML does is it helps us evaluate different model types, and then it recommends the right one based on what is the best run fitted model that is suited for our data set. So once that is done, thanks to the native support for Onyx, the winning model can now be easily exported to Azure SQL Edge. Now let's see how the model that we have trained here can be used with Azure SQL Edge. So after loading it into the table, we can reference it using the native predict statement over here. So let's fetch the latest data for a particular ventilator and then use it to make a prediction on whether it's likely to be nearing a failure. So once that is done, you will see here that for the purpose of this demo, we are looking at 20 different ventilators, and out of which there is one ventilator which has label 1, meaning it is up for service sometime soon.
And by sharing this same data with my medical colleagues, they can remotely review and validate the device configuration irrespective of where they are located and take timely action as needed. Through this demo, we saw how Azure SQL Edge's features such as native data movement, streaming capabilities, ability to handle time series data, and built-in machine learning played a key role in not just hospital asset management, but also empowering medical professionals to pursue the best outcome for their patients. With that, over to you, Rohan.
Thanks, Basia. I'm humbled to think that a portion of our work goes into helping ensure our most vulnerable neighbors are getting the care they need. It's amazing to think about what you can do with all the rich capabilities and the power of SQL Server, capabilities you're familiar with and know how to use when it reaches out to the edge. Of course, amazing isn't limited to the edge. There's a massive amount of innovation happening on premises too. SQL Server represents the foundational database for our SQL-based technologies in Azure. With more than 25 years of history, we've been collaborating with you to continually evolve SQL Server to meet the needs of the modern data platform. SQL Server 2019 provides the industry-leading performance and built-in security you expect, but it also enables you to apply intelligence across all your data. With the SQL Server Big Data Clusters capability, you can use familiar tools to make sense of all your structured and unstructured data. Easily access high volumes of data using either SQL or Spark and combine it with different data types from many sources, including Oracle, Mongo, Postgres, and others. On top of that, you can use built-in AI capabilities for comprehensive analytics over all your unified data. While SQL Server continues to grow, our commitment to leading performance and security is constant. SQL Server 2019 builds upon this legacy with even faster database recovery and security features like secure enclaves. It's no wonder that SQL Server is the least vulnerable database over the last 9 years. More than ever before, SQL Server is about providing users choice and flexibility. Whatever workloads you need to manage, SQL Server supports your choice of language, OS, and deployment, whether that's Windows, Linux, or Docker and Kubernetes. I'd like to share a little more about 3 components that go into providing intelligence over all your data. The first is enhanced data virtualization, which allows you to combine data from many sources while avoiding data movement or replication. The second is an HDFS data lake, accessible through either SQL or Spark, with a single admin portal and integrated security for simple management. And the last is a complete AI platform that lets you ingest and prep data from many sources and then train, store, and operationalize your models all in one system. This is a huge benefit to organizations with lots of different data types coming from many sources because unlocking diverse data helps your businesses achieve more. Wherever this data lives, SQL Server is the hub for all of it. So as you can see, we are bringing in Spark, we are bringing in HDFS, and we are expanding SQL Server with the best and broadest capabilities to help you do more with your favorite database. More recently, we've been working on bringing Azure Security to your on-premises SQL Server deployments. I'm excited to announce the general availability of Azure Defender for SQL Server on-premises. Azure Defender for SQL provides vulnerability assessments and advanced threat protection, triggering alerts when there are potential SQL injection attacks, brute force attacks, unusual access attempts, and suspicious database logins. Now you can get the security of Azure across your entire SQL estate on-premises, in Azure, or in other clouds. Let's bring in Buck Woody to demonstrate how SQL Server Big Data Clusters, Azure Data Studio, and a single math theory can help law officials sniff out money laundering. Take it away, Buck.
Most of the time when we talk about technology, we start off with the technology, and we begin to explain how the technology works, and then we come up with a problem, and then we show a solution at the very end. We combine data from relational sources all the way through larger and larger data sets, and we tend to show off artificial intelligence and machine learning and other data science constructs, and that's fine. But what if we reverse that a little bit? What if we come up with the problem first and then talk about how you might solve it, and then we use the technology to do that? So I looked around for a problem that we've been working on lately, and one that's very interesting is something about money laundering. Money laundering is a problem where you the criminals move money from illegitimate sources to more and more legitimate sources. And so once they've done that, it's very hard to trace. But as they're doing that, there's an interesting math construct that tends to come up. Now we'll get here in just a moment, but this large formula you see here is something called Benford's Law. And Benford's Law is very interesting in that it states if you take a random distribution of numbers, just take a big distribution of numbers, the leading digit on those numbers will be a 1 30% of the time. and the leading digit will be a 2 around 17% of the time, and a 3 around 12% of the time, and then it falls off. Now, the reason this law is kind of interesting is it helps us look for patterns within data that don't match a law, and then we can begin to suss out, hey, there may be some faking going on here. When you're working with huge sets of data, it's difficult for a human to meet this law. They'll usually violate it. So let's take a look and see how we can do this, solve this problem in technology. So I'm using Azure Data Studio here. If you've not dealt with this tool before, it's a cross-platform tool you can use to manage and interact with lots of data systems. SQL Server, Postgres, SQL Azure, and so on. I'm going to use a big data clusters today because I want to work with a large set of data. So to start with that, normally we pull data in and we begin to do ETL, extract, transform, and load. But we're not going to do that this time. What we're going to do instead is do extract, load, and then transform. So using this tool where I can, you've got some nice views here, you've got machine learning wizards and so on that can work you through this. Again, it can connect to multiple data systems, which is incredibly useful. But one of the things we're going to do here is we're going to start off with a Jupyter notebook. And a Jupyter notebook is nothing more than some text, like you see here, and then some code. And the code runs merely by the kernel you pick. And you'll notice in SQL Server, Azure Data Studio, you're actually able to talk to SQL, Custo, Spark, PySpark, Python, PowerShell, and again, just regular old everyday SQL, which is what we'll do in a moment. So I've actually connected in the SQL Server Big Data Cluster, which combines SQL Server, a data mart feature, and it also has Spark and even HDFS, all within the same security boundary and all within the same management construct. So what I'm going to do here, I'm a data engineer at this point, and so I've logged into my Spark cluster, once again, just using big data clusters in Azure Data Studio. And I'm just going to bring in some data from around the world. Now, some bank branches have sent me some things, some account transactions, some digital transactions, and they've actually pulled down from their government sources the risk involved with certain factors. And so I've got all this data. Now, when Spark works with data, it simply copies it up into memory and writes lots and lots and lots of files down in HDFS. Now, SQL Server doesn't normally work with HDFS. One is relational data and one's non-relational. So we're going to take a look at how this works just to show you kind of where this is. When I open my big data clusters, you can see I have an HDFS file location, which normally you have to talk to using, MapReduce or some other language, but we're going to see if we can bypass all that. I've brought this data, I've opened it up here. Let me just put this away. I've opened it up here, and now what I'm going to do is just take a look at it. This is just standard stuff. These are sort of my columns, if you will, although this is comma separated values. No real columns there. And I bring in the data sets, and now what I'm going to do is I've done the the extract, and I've done the load. Now I'll do the transform. So we're doing ELT, not ETL. And what I'll do here is I'll just simply combine my data sets by joining on a key column. This is something we might do inside SQL. Now I'm using PySpark, which is Python, but Spark actually has other languages you can use. There's R, you can use an SQL variant, and so on. So now I'm just going to take a look at what I did, and you can see that here is the new data set. So all I did was take in 3 files. These could be huge files or tens of thousands of files from around the world, and Spark does that very well, spread out that way and be able to do that. Now what we want to do is I just want to do a little cleanup. Not much. I could do it a bunch here, but I'm just going to do a little. I'm just going to drop my duplicates here, and I'm just going to fill my NAs, and that's a null value inside Python for those of us who are SQL ready. And that's all I've done. So I simply got rid of duplicates, and there was a particular column that I wanted to fill the null values, and then I'm just going to write it out. But this is what's interesting. I'm writing it out to a directory. That's all I'm doing. Now there's thousands of files under there, and I don't want to import them into SQL Server, and I would like to use Benford's loss. Let's take a look. Let's go out here to our advanced analytics at scale here, and the first thing I'm going to do is simply say, hey, I want to work with comma separated value data. There that is, and that was easy to do, just a comma and a Linux line terminator. And then what I'm going to do is just simply point to where that HDFS is. That happens to be this. And then all I have to do is create a table. So I've created a regular table here, but the interesting thing about creating this table is I simply tell it, it's out here, that's the name of it, and that's the thing we just created, and this is the directory, and it's a CSV file. I have not pointed at the file. I am not importing the data. I'm simply pointing to it, and then I can treat it as if it's SQL Server. It's no difference. I can join it, I can do column selections, all the kinds of things that I do in Transact SQL. Now normally here I would go off and do my machine learning to create a machine learning model. But let's apply that Benford's law to this data to see if this data that I brought in from around the world is fake in any way. So here's what we'll do. I'll go get this, and believe it or not, this is pretty much Benford's law right here with this sort of subselect. So that's all I have to do to get Benford's law. Let's take a look at the results. This is fascinating. And so here's what it is. The first digit should have been 30% of the time, should have been a 1, and it's 11%. And you can see that the first digit should have been a 2, 17% of the time, it's 11%, and so on. In fact, look at this distribution. You'll notice it's 10 or 11% every time. Now, this not only shows us that we're violating Benford's law and that this data set should be evaluated further, but it actually shows me, because of this perfection in layout, that it was probably done by a computer. Humans would not normally come up with this level. Well, what you've seen so far is we can actually come up with a machine learning model now to predict this fraud detection and this money laundering further out, SQL Edge, in the cloud, and so on. We've done all this inside a single security boundary and big data clusters using the Azure Data Studio tool and good old everyday Transact SQL.
That was great, Buck. Thank you. What an interesting way to fight crime. And I just love that you used T-SQL. I'd like to finish this section by sharing a story with you. Dr. Foster, a London-based healthcare analytics company, used SQL Server big data clusters to provide healthcare teams access to huge data sets while protecting sensitive data. Let's watch and see how they did it.
We provide advanced analytics and benchmarking services to healthcare organizations looking to make better and more efficient decisions.
So one of the big projects we've been doing is looking at patient-level data for COVID patients who've been admitted to trusts, and we've been then able to run analytics on the patients, which at the moment is really key in understanding which patients are at risk and also understanding the differences between how they treat their patients. They've also been able to understand where the biggest burden is in their trust and been able to really redistribute their resources.
As we've started using SQL Server 2019 big data clusters, what we have now is effectively our unified data layer and a single source of truth for all the analysis that we do, and that's massively important.
We selected SQL 2019 big data clusters as a way of being able to master and keep up with changing technology to enable our statistical analysts to be using the latest tooling they need for AI, machine learning.
The technology is key to make sure that we can do all the kind of machine learning and AI that we need to do.
We need to be able to access like several hundreds of terabytes of data. That's data for every hospital in England. We need to be able to access it quickly and shape it and make sense of it. SQL allows us to do that with speed and with accuracy and helps us keep it safe.
I think the work we do can be incredibly rewarding when you're able to help a hospital and being able to see that impact in terms of their data over time when they've made a change, and you can then see that increase in patient outcomes over time. It's incredibly rewarding to see that.
So far, we've talked about 3 major locations where you can run SQL: in the cloud, at the edge, and on premises. If your environment consists of 2 or more of those elements, though, you're running hybrid. And when it comes to hybrid, our goal is to meet you where you are and help you apply the same innovations and benefits that we build into our managed databases to any infrastructure, whether that's on-premises in data centers, on the edge, or in any other public cloud. Azure Arc is a set of technologies that extends Azure management and native data services outside of Azure infrastructure to simplify your data management for better consistency and greater productivity. So even if you can't migrate to the cloud, due to data sovereignty, latency, or regulatory requirements, you can still get the efficiency and agility it offers. With Azure Arc, you can use any major distribution of Kubernetes on hardware of your choice to run Azure Data Services over workloads anywhere, giving you a number of unique benefits. Azure SQL Managed Instance and Postgres Hyperscale are the first set of services now available in public preview. First, you get a versionless evergreen SQL that ensures you're always current. This full automation of updates also applies to PostgreSQL databases running on Azure Arc. Second, you get the cloud elasticity on premises, which allows you to optimize performance of data workloads and dynamically scale up and down and out without application downtime. Third, Azure Arc offers unified management, which allows you to see your data services running on premises alongside those running in Azure through a single pane of glass, and manage them using familiar tools like the Azure Portal, Azure Data Studio, and Azure CLI. You can also get Azure's industry-leading security and governance capabilities by using Azure Security Center, Azure Policy, and Azure RBAC to protect your data on premises. One key call out here is that with Azure Arc-enabled databases, you get the automation and elasticity support even for data workloads running in places where you don't have a continuous connection to the public clouds or any connection at all. And Azure Arc also gives you the option to use modern cloud billing model for better cost efficiency across your hybrid infrastructure. No other cloud vendor offers a solution like this that unifies management of all your databases, bringing the benefits of Azure to wherever your data resides. We continuously look for ways to help you get even more value from your existing investments. As we mentioned earlier, Azure Arc-enabled SQL Managed Instance and PostgreSQL Hyperscale are in public preview. We first announced this at Ignite back in September. This means you can download the Azure Arc Data Controller from the Azure portal to run self-service deployments at scale and monitor local and Azure-based assets in a single view. Travis Wright is here with us today to demonstrate how to deploy and scale out PostgreSQL Hyperscale in Azure Arc using Azure Data Studio. Travis, thanks for joining today. I'm excited to see this in action.
Thanks, Rohan. Hey, so in this demo here, we're going to show you how Azure Arc-enabled data services helps you automate everything from provisioning to deprovisioning and editing the configuration of things. And then we're going to show you how with PostgreSQL Hyperscale, you can distribute your data and spread it across multiple compute nodes for even more compute power for your data, and do so on any infrastructure, whether it's in your data center, in another public cloud like AWS or GCP, or even in an edge site location like a retail store. So let's go ahead and dive right in.
GitOps is an exciting and popular new pattern for deploying applications and configuration changes. It uses a Git source code repository as the desired configuration management system along with automated workflows to deploy. In this example here, I'll use a GitHub repository to control the deployment of test PostgreSQL instances via Azure Arc for my CI pipeline. Here I've staged a pull request. Before we merge it, let's take a look at the files of Postgres instances. The first one is pgdemo1, and here you can see the CPU, memory, and storage configuration. Down here you can see another YAML file describing a second instance, pgdemo2. Now let's go ahead and merge in this pull request. Switching over now to Azure Data Studio, I'm going to run a command which will use AZData to list the currently deployed Postgres instances and refresh that every 5 seconds. We can see that there is currently just one deployed. If we give it a few seconds, we will see that the Azure Arc agent that is monitoring the GitHub repository will recognize that there are 2 new YAML files that need to be deployed to Kubernetes, and we will see those Postgres instances start to come up. You can also use the Azure Data Studio dashboards to view the deployed instances, and then you can drill into an instance to see the details about it. You can also use Kubernetes native tools like kubectl to view and edit details about the instances. First, I'll run a command to show the Postgres instances using kubectl get pg12. You can see that Arc-enabled data services is fully native to Kubernetes using custom resource definitions. Now we can view the details of a given instance using kubectl as well by typing kubectl describe pg12 and the name of an instance.
We can also take a look at the pod deployments and see that this scale-out PostgreSQL hyperscale instance is actually deployed as 5 pods, which matches the configuration that we see above here. Lastly, we can see the configuration of the services, which shows us the endpoint to connect our tools and applications to. And that also matches the configuration up here above. Let's switch over now to another Azure Data Studio window where I am connected to another Postgres instance, PG01. In this instance, I have a database with a couple of sharded tables in them. The events table has a couple of ID fields and a JSONB data type column storing the event data. Let's run a couple of queries. The first one is a simple SQL query, but in this case the query is running over 4 different distributed nodes, which we'll see in a minute. The second query is showing how we can join JSONB data to relational data and still do that across multiple nodes. Next, let's take a look at what the data distribution looks like currently. We can see that the data is fairly evenly distributed. It's even easier to see if we switch to showing a graph here. Now let's see how the nodes are currently laid out by running a standard Kubernetes command. Here we can see that there are currently 4 Postgres instances, and each of them is deployed on a different Kubernetes node, ensuring that there is no resource contention at the time that we run a query. Now let's scale up the number of nodes by running the command azdata arc postgres server edit, specifying the name of the server and 8 worker nodes. While that scaling operation is happening, of course we can continue to run queries against the instance. Now that the scaling operation is done, we can kick off the rebalancing of the data by running this query. While the rebalancing of the data is happening, we can still continue to run queries. If we run the same query we did before, we can actually use the chart to see the rebalancing happening live. So here we're partially rebalanced. If we run the query again, we can see that it'll be even more rebalanced. And if we run it maybe one more time, we can see that it should finally be completely rebalanced now. There we go. Lastly, let's check back in again with the pod layout and see how that looks after the scaling. As you can see, we now have 8 worker nodes, and each of them is intelligently placed on a different Kubernetes node to ensure no resource contention. In this demo, you've seen a variety of ways that Azure Arc-enabled data services makes your DevOps life easier, faster, and more efficient, and how PostgreSQL Hyperscale can seamlessly scale with no application downtime on any infrastructure, edge sites, your data center, or any public cloud. Back to you, Rohan.
Thanks, Travis. It's amazing to see how easy it is to add nodes and redistribute the data online while still having access to your business-critical workloads in real time. I'd like to share one final story with you about how our customers use Azure Arc to extend Azure to their on-premise systems. Ferguson Enterprises is the largest wholesale distributor of plumbing supplies in the United States. They run a complex IT environment made up of multiple clouds and more than 5,000 on-premises virtual machines across 2 data centers and 1,400 distribution centers. Across all these machines, the company needs to apply consistent policy and understand which ones are really part of which applications. Beyond that, though, the IT team also wanted to find a way to deploy standard images of DB builds across the entire organization. They wanted to leverage the management capabilities of the cloud, and they wanted to provide a single view of their data and analytics to decision makers. The team chose Microsoft Azure Arc to extend Azure to their on-premise data centers. They did this by migrating their SQL Server database to an Azure Arc-enabled SQL managed instance and enabling it to use Azure Arc features such as automated updates, backup restore, and monitoring. Using Azure Arc, Ferguson was able to apply grouping and tagging from the Azure portal to inventory all their servers. Then, through Azure Policy, they were able to monitor and enforce configurations. This was their first entry into a cloud platform. It was a complex project due to the inputs, but the team leveraged their economies of scale to migrate data into Azure Arc-enabled SQL managed instance in less than 10 minutes and get to work immediately using the familiar tools in Azure Data Studio. That's the power of Azure Data Platform. So Azure Arc helps you extend Azure services to non-Azure products, which is great if you like what you have running already. But if you're running OSS or NoSQL on infrastructure you manage yourself, or if you're running it on a cloud that doesn't offer the security and reliability of Azure, you might be ready for a change. The Azure platform includes fully managed database services for your favorite OSS or NoSQL database. Plus, it provides the security and management tools you're used to on Azure and supports common languages and frameworks. For PostgreSQL, we offer Azure Database for PostgreSQL, which includes built-in high availability and continued investment in the Postgres community. Our hyperscale tier provides high performance, horizontal scale-out across hundreds of nodes and delivers blazing fast performance with sub-second responses across billions of rows. We continue to invest in making Azure a preferred destination for MySQL and MariaDB workloads as well. Azure Database for MySQL or MariaDB provides fully managed database, low total cost of ownership, and the rich Azure developer ecosystem, all combined with the openness of the community database version. Last but not the least, among our open source database services is Azure Cache for Redis, which helps you accelerate performance of other Azure databases by adding a lightning-fast caching layer to scale I/O, throughput, and lower read latency. In fact, in a recent study by GigaOM, we found that Azure Cache for Redis can increase throughput performance by over 800% and latency performance by over 1,000%. Then there's our fully managed NoSQL database service. Azure Cosmos DB isn't derived from open source the same way MySQL and PostgreSQL are. But with Azure Cosmos DB, you get the scale and flexibility of Azure behind your NoSQL data. It's the only service like it with financially backed SLAs for single-digit millisecond response times and 5 nines availability. Running on Azure Cosmos DB, you can independently scale storage and throughput across any Azure region to put your data where your users are. Its APIs for MongoDB, Cassandra, and Gremlin let you bring your existing data to the cloud and use familiar frameworks and SDKs. More recently, we've rolled out new autoscale and serverless offerings to give you better control over costs without requiring you to manage capacity so tightly. I know we've only scratched the surface of these services, but I want to reinforce that we are fully committed to supporting them. And we are dedicated to helping you bring together your entire data environment. Let's close this section with a video from JetBlue that explains why they chose to use Azure, specifically Azure Cosmos DB, to calculate optimal fuel needs for a flight plan.
Airline industry has one of the lowest margin industries out there. And it's very easy to make a loss in a flight. An airline is made up of many pieces. Planes, it involves people, pilots, in-flight, airports, it involves customers, which is all of you, buying, selling, cancellations, transactions. All of these systems can only work seamlessly when they're connected. You can only imagine if an API call takes seconds to come back, that's no more an API, right? That becomes a back job in this modern world. So you need milliseconds, microsecond response time. And that's when we encountered the Cosmos DB. We use Azure to calculate optimal fuel needs for a flight plan. When we were looking to build our API database and the API engine on which to run our user interface, our .com interface, and operations interface, we needed a database that was fast, that doesn't need to be indexed. What's done with cloud is, A, the data has become easier, it's faster to get to that, faster to do all these calculations, and now not just linear programming, you're able to create new models, machine learning models on top of that to help augment and be more predictive about these, whether it's ticket pricing and so routing and so making sure that the right people, our customers, are being provided for. You need something that aids you in doing this well, right? In order to give the best customer experience.
It's so interesting to see what Ramki Ramaswamy and his team at JetBlue are doing with Cosmos DB. Did you happen to catch what they were doing to run models? Azure Synapse Analytics, specifically Synapse Link for Azure Cosmos DB. But I'm getting ahead of myself. The Azure Data Platform offers two options for performing cloud-scale analytics: Azure Databricks and Azure Synapse Analytics. Azure Databricks offers a fully managed Apache Spark environment. That means you get the same global-scale enterprise-grade security and availability of Azure running the latest version of your favorite Apache Spark engine. And both services provide industry-leading performance for cost. Azure Synapse brings together enterprise data warehousing and big data analytics without limits. It gives you the freedom to query data on your terms using either serverless or dedicated resources at scale. Recent TPCH benchmarks have shown that Azure Synapse runs up to 14 times faster and costs 94% less than other cloud providers. Likewise, Azure Databricks on Delta Lake with Photon performs up to 20 times faster in TPC-DS benchmarking than other big data engines. Azure Synapse runs deeply integrated Apache Spark and SQL engines, allowing data professionals who prefer SQL to seamlessly collaborate with those who prefer Spark and vice versa. For instance, now you can query Spark tables using the T-SQL language, or use languages like Python, Scala, Spark SQL, or C# to work directly in the service that houses your data pipelines, data lakes, and data warehouses. All this functionality is supported by integrated data management and security. The result is an easy-to-use service for both structured and unstructured data. The distributed cloud-native SQL engine of Azure Synapse is the first and only analytics system to run all TPCH queries at petabyte scale. We are talking truly limitless scale. With Azure Synapse, you can build end-to-end analytics solutions without having to stitch numerous services together. The unified experience in Synapse Studio helps you ingest, prep, manage, and serve data for immediate BI and machine learning needs from one place and extend insights by applying models across all your data. And you can easily and securely share data with just a few clicks using Azure Data Share integration. For immediate in-the-moment insights from operational data, we've added Azure Synapse Link for Azure Cosmos DB. This is what they used in the JetBlue story to help them get their API calls down to milliseconds. In the future, we will also support Azure Synapse Link for SQLDB. By adding the link between Azure Cosmos DB and Azure Synapse, you can get insights from your live transactional data stored in operational databases with a single click without moving data or burdening the operational systems. It's another way to accelerate time to insight and use the power of Azure Synapse across your entire data stack. I'd like to wrap this section on cloud-scale analytics by sharing a video that shows one of our customers, NeoGrid, using Azure Synapse Analytics to synchronize activities across their supply chains.
Picture the last exciting thing you bought. Shoes, a TV, a bike. Now imagine not having it because it wasn't in stock. Disappointing, right? NeoGrid makes sure these supply shortages never happen. They do it by collecting millions of data points across the supply chain to forecast demand. Using analytics, they help retailers and manufacturers ensure their products are always available and never in excess. But NeoGrid's data warehouse infrastructure was nearing its capacity. Adding additional storage would have been costly and labor-intensive, and still wouldn't offer the scale they needed. So they turned to Azure Synapse Analytics. With Azure Synapse, NeoGrid now has an end-to-end analytics solution with limitless scale and better performance, all at a lower cost. Its powerful data warehousing capabilities let NeoGrid run an around-the-clock process to ingest and analyze retail, manufacturing, and logistics data as soon as it's available, giving retailers fast, actionable insights to help balance their inventory in near real time. Azure Synapse reduces the time it takes NeoGrid to provide point-of-sale data to manufacturers, helping them better synchronize their production flows with retailers' needs, keeping excess low, profits high, and your favorite things in supply.
Okay, So after you analyze your data using Azure Synapse Analytics, you need a way to visualize and understand the insights from it, right? Cue up Power BI. As you probably know, Microsoft Power BI is a unified self-service, enterprise-grade business intelligence platform that combines an intuitive user experience with intelligent data visualizations to provide greater depth of data insight. Power BI works across the complete Microsoft cloud, meaning reports can be shared within Microsoft tools like Teams, SharePoint, PowerPoint, or within other productivity products. That way, you have it in the assets you need without versioning issues, and when you're working remotely, you can collaborate with others to respond to changes more easily. T-Mobile has an interesting history with Power BI and how they've used it to expand into the Microsoft cloud on their own terms and at their own pace. We've been working with T-Mobile, the wireless service provider, for a while now. Last year, they chose Power BI to serve valuable information to everyday decision makers. The user-friendly service allows teams to easily interact with and derive meaning from data of any complexity. In the process of fast-forwarding their business intelligence a decade and a half, they also cut their costs tremendously by getting rid of their legacy system. What makes the story even more interesting, though, is the recent launch of a new application, Orbit. The company, or more accurately, a single person, developed the workhorse of an application by building it on the Power Platform, of which Power BI is a main component. While the app itself might not be the flashiest, I love this story because it was about one person in a huge company that took what he had and what he knew and changed the way his company thinks about their business. It's what I wish for all of us. To close out our time, I'd like to bring in Anita Adusumilli. She's going to pull together a lot of what we've been talking about today as she demonstrates using Azure Cosmos DB Serverless with Azure Synapse Analytics to run T-SQL queries over IoT data and visualize the results in a Power BI dashboard. Anita, thank you for joining me.
Thanks, Rohan. Hi, everyone. I am Anita Adusumilli, Principal Program Manager from Azure Cosmos DB team. Thank you so much for taking your time to join us here today at the Data Platform Virtual Summit. I'm very excited to be here with you all to share the improvements that we've made for our Cosmos DB service. For today's demo, please imagine that I work at a logistics company that delivers cargo to our customers at various locations. One of the important functions of the company is fleet management, the ability to assess the state of vehicles and be able to react to any events in real time. I'm building a prototype that is consuming the vehicle telemetry information that is coming in at high throughput. I want to assess if Azure fits our throughput requirements. Now let's see how I got this prototype built. Azure Cosmos DB is the right choice for storing the vehicle telemetry data, given the low latency reads and writes and high availability. With serverless provisioning mode, we are also excited that it is very cost effective for us to get started, since we'll only be charged for the resources and the storage that we use. Let's see how we build the prototype. All of our vehicle telemetry data is arriving into IoT Hub. The vehicles are registered as devices here, as you can see, and when they push the telemetry, it triggers IoT Hub event. Now I have built a simple function that reacts to these IoT Hub events and pushes the data into Cosmos DB. Writing this Azure function is super simple. With a few lines of magic, you can push the data into Cosmos DB. Alright, so now that the data is moving to Cosmos DB, let's take a look at the account here. Here's a Mongo account that I created with serverless capacity mode. This setting is enabled when I'm creating the account. Just toggle the capacity mode from provision throughput to serverless. Alright, so now moving back to the account, let's take a look at the collections here. In the metadata collection, we have information about vehicle such as VIN and some information about battery. We also have information about consignment, packages, etc. This is more static information. Now, telemetry collections is a place where a lot of information from the vehicles is landing in real time. Each of the vehicles can push multiple items like these. So you can see information like engine temperature, fuel, engine oil, tire pressure, etc. that indicate the state of the vehicle. All right. So with this information in, we are able to build a web portal for our employees to be able to monitor the vehicles, consignments, etc. So you can see that for a given vehicle, they can quickly view the data from the metadata collection. The cool thing is they're able to edit the vehicle or be able to create new vehicles right here from this UI. And they can also search information about a given vehicle. Now, if you were to determine the state of a vehicle using all the live telemetry data, those sort of queries would be very expensive on the transactional workloads. They could impact the pipeline that we built to store the telemetry data into Cosmos DB. This is where we're super excited about Synapse Link. With Synapse Link, we get to do analytics on the Cosmos DB data without any performance impact to the transactional workloads. Let's see how we got started with Synapse Link now. Now here's another account that is also storing the telemetry information. It's the same schema as what we've seen. It's just that we've pushed more telemetry information here for deeper analysis. For any account, if you navigate to the Data Explorer, you can click Enable Synapse Link setting, and then for every collection or the container that you create, you can turn on Analytical Store. This is the magic that starts replicating our telemetry data automatically into a format that is ready for analytics. This triggers a creation of an isolated columnar store that is suitable for large-scale analytics. Alright, so now that the data is ready for analysis, let's switch to the Synapse Analytics where we can look at this data. Now, linking Cosmos DB to Synapse Analytics is super easy. Just navigate to data here in Synapse Analytics, click on Add New Link Service, connecting to the external data, pick the MongoDB API, provide information about the account and database name, and that's about it. With few clicks, we are able to connect the Cosmos DB account. Here it is, and here are a few collections that we looked at earlier. Now, if we click on any collection, you can see that I can launch Spark notebooks and load them into data frames, be able to do some joins, or I can perform familiar T-SQL queries against my data now in Cosmos DB. How cool is that, right? Now, here are some queries that I've put together already, so let's take a look. Here you can see a simple query that is using automatic schema inference. It takes in the account and the database name. You can also specify the schema if you wish, and notice how I've given the data type field. We retain all the data types in the mixed data types properties, and you'll be able to pick and choose what you wish to use, which is pretty cool. You can create SQL views over your collection. So here's one I've put together for metadata, and one I've put together for telemetry. I won't execute them because I ran them in the past. And how do we use these views, right? Now you can use these views to do joins, to perform more complex queries. Here I'm querying for all the vehicles that meet certain daily trip duration. I want to know the statistics of how these vehicles are doing. Now let's execute that. And now we can also write more powerful views. As you can see, I'm combining the telemetry and the metadata view to build a combined vehicle fleet view, which could be super helpful when building a BI dashboard. Now let's switch to the BI dashboard as this query is running. Here's information about all of our state of vehicles. Now our fleet managers can quickly know where the vehicles are located globally, stats about all of our vehicles, and here's, it's reflecting the stats of the vehicle that got selected. So if I were to, let's say, pick a consignment that is delayed, very quickly I can notice which vehicle got impacted, and I can also see that the engine temperature is pretty high, and so we need to reach out to the driver to ensure the safety and ensure also that the cargo gets delivered to our customer. All right, that's great business insights using Synapse Link. Now let's take a look at the query to see if it is finished executing. All right, here are the results, and you can see that for every vehicle, we can see the aggregate stats, which is super cool. In summary, Azure Synapse Link makes it easy to get insights on our real-time Cosmos DB data. With serverless provisioning, it's also now super easy and cost-effective to get started with Cosmos DB. We are very excited about these capabilities, and we hope you give them a try. Thank you, and back to you, Rohan.
Thanks, Anita. It makes my DBA heart race to see how easily you can manage data from all those different sources using T-SQL. Love the way you were able to avoid provisioning for peak scenarios to save money too. I can see why Cosmos DB is the most cost-effective way to run NoSQL applications. There's really no telling how long we'll be in this virtual world, how businesses and industries will continue to change, or what new thing we'll all be doing from home next week. But in these uncertain times, we want you to know that, even more than ever, you can count on us. We are in this together, and we deeply admire the way you've risen to meet the new challenges of your role, enabling digital transformation for your organizations of all sizes. We'll keep doing what we do best, looking for ways to help you drive innovation across new technologies, legacy databases, and multiple clouds. You keep doing what you do best, making our world a better place. And we'll meet up again soon. Thank you so much for joining me today. Enjoy the rest of DPS.
Thank you, Rohan and team, for the wonderful keynote. It is truly exciting to see all the innovations that are being made to the Azure Data Platform and the efforts towards empowering data-driven organizations. So friends, the next 70 hours, there is incredible amount of learning and networking available at DPS 2020. As you know, there are breakout sessions, technical live roundtables, data and AI Gurukul, community zone, and the most important, Expo Hall. Visit every sponsor and exhibitor, and there are raffles running. Participate in the surveys, and you have the opportunity to win some wonderful prizes. Enjoy all of this from the convenience of your home or office. And most importantly, stay safe.